Hello everyone. In this example, a man pushes a lawn mower of mass 50 kilograms across a field at constant speed. We are asked to calculate the work done by the man. Now, when we say that calculate the work done by the man, what we simply mean is that you should calculate the work done by the force he exerts on the lawn mower. So let's see how we're going to approach this problem. So we will start first by drawing a free body diagram. He exerts a force F at a certain angle, theta. Now, the lawnmower moves with a constant speed. What that means is that the sum of forces acting on the lawnmower is equal to 0. So let's start first by doing our free body diagram. You have the weight of the lawnmower acting vertically downwards. You have the normal force acting vertically upwards, N, and there is friction, K, acting backwards. So what we can do is we can resolve the force F into two components. You have, this is F, this angle is theta, so this will be F cosine theta, and this will be F sine theta. So if we consider the fact that the system is moving with a constant speed, we can therefore see that the summation of Fx, which is equal to F cosine theta minus the kinetic friction, all of this will be equal to 0. Similarly, the summation of Fy, this will be equal to N minus F sine theta minus mg, all of this will be equal to 0. What that means is that N is equal to mg plus F sine theta. So by definition, the friction force F sub k is equal to mu N, which will be equal to mu mg plus mu F sine theta. But we want to calculate the force F. So we know that from equation 1, we can see that the force, from equation 1, we can see that F cosine theta, F cosine theta is equal to the kinetic friction. So F cosine theta will be equal to mu mg plus mu F, the sine of theta. Mu F, the sine of theta. This would mean that F cosine theta minus mu F sine theta equal to mu mg. In other words, F bracket cosine theta minus mu sine theta will be equal to mu mg. So what can we conclude? We can therefore see that the force F will be equal to mu mg divided by cosine theta minus mu sine theta. So this gives us the magnitude of the force F. But we have been asked to calculate the work done by F. In that case, the work done by F is equal to that force F multiplied by D, the cosine of the angle the cosine of theta, where theta is the angle between the force and the displacement vector. So this will be equal to mu mg cosine theta divided by cosine theta minus mu sine theta. You can leave it here, or you can divide both sides, the numerator and the denominator, by cosine theta. If you do that, the work done by F will be equal to mu mg divided by 1 minus mu, the tangent of theta. The tangent of theta. So this will be the expression of the work done by the force F. So please, if you have any question, I will appreciate it if you can ask in the discussion forum below this video. Thank you so much and have a wonderful day. Bye bye.